All right, we are at loops. This is going to be a ton of fun, absolutely worthy of playing with the Stream Deck and putting on the yes. Finally, we're at the point where we're going to have programs that are going to have continued interaction. It's not just going to be a one-off, you run it and the program ends. Instead, we're going to continually be interacting with the user, a lot more fun. You'll want to have a little bit of programming humor, pause the video, maybe it's funny, maybe not. Let's jump right into this. The motivation here is we want to be able to have a more effective or efficient way of performing a given task multiple times. So imagine if you were asked to print a given sentence 100 times. Until now, the only way we know how to do that is to literally make a print statement that would do that 100 times, and it would be a disaster. Print, programming is fun, and you had to come over here, print, programming is fun, and you want to do that 100 times. You can do it pretty quickly, copy paste, right? 1, 2, 3, 4, 5, no, that's 6, 7, 8, 9, 10, and sure, I could come take that and then do those 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. There we go. We have 100 prints of programming is fun. That's crazy. No one would want to write 100 lines to print programming is fun 100 times. That's insane. There's got to be a better way. Of course, there's a better way. That is with looping. So this is a common example that is often used to introduce loops. The idea that we could print something 100 times with 100 print statements, but instead of doing that, what else could we do? We can use loops. And so here's just a bird's eye view, a trailer to the movie, if you will, to get an understanding of just at a more broader level of how loops work and how they can help us solve this problem. So if you notice, we have this while loop here where it says while count is less than 100, print programming is fun. So we have a counter that we're using. And notice what happens as soon as we print programming is fun. What do? We then increment, we update that count by adding 1 to it. So it started at 0 and now it's 1. And when we go back to the while loop, and we're going to go over this in detail, again, this is just the trailer. Now count is 1. Is 1 less than 100? It is. So that is still true, and we're going to loop again and again and again until this condition right here becomes false, at which point we will exit the loop. So those 4 lines of code could be used to replace all 100 of those lines right there. Big, big difference. So Python gives us 2 types of loop statements. We have while loops and we have for loops. While loops are what we're going to start with, and there's some wisdoms there. Arguably, they're both very easy once you've practiced with them. For loops in Python are particularly very easy, an extra level of easy, if you will. So why don't we start with them? Because if we start with for loops, students may be building like mental obstacles or mental blocks of, oh, I don't want to do a while loop now. But in fact, they have 2 different purposes. A for loop, which I'm about to show you, has more of it's used for counter control loops when you know how many times you want to loop. That's ideally when we would use a for loop, whereas a while loop can be used for that same purpose when we're counting the number of times to do something. But a while loop is actually even better, that we can use a while loop when we have an open-ended number of times that we need to repeat something, an unknown number of times. That's when we would use a while loop. So a while loop is a condition-controlled loop where we will keep looping as long as a given condition is true, and we will only exit and stop looping once that condition is false. So we will execute this statement repeatedly, or many statements repeatedly, so long as a given condition is true. Whereas a for loop is strictly a counter-controlled loop that will repeat a certain number of times. We're going to study both of these exhaustively. It's going to be a lot of fun, but we're going to start with while loops. So here's the syntax. While loop continuation condition. And what is this loop continuation condition? That's going to be our Boolean expression. similar to inside an if statement. We have if Boolean expression, and we only execute that if statement when that Boolean expression is true. Well, in that same vein, we're only going to execute what is inside this while loop only when the given Boolean expression is true. And we will keep iterating. That's a word we're going to learn. We're going to keep looping and keep iterating. Those are synonyms. We'll keep looping, keep iterating as long as this Boolean expression remains true. So here's a flow chart on the right. We have this Boolean expression, this loop continuation condition. If it's true, we will perform whatever is inside the loop, and then we're going to come back again and retest this loop continuation condition. We will once again test this Boolean expression. If it's still true, then we once again perform the statements inside the loop and we retest. We keep looping. We keep performing what is inside the loop and we keep testing this Boolean expression. As long as it's true, we keep going. But at some point, when that Boolean expression becomes false, that's when we exit the loop and we no longer execute the statements inside the body of the loop. As mentioned, a single execution of the statements inside the body of the loop, that is called an iteration. One iteration is, you could say, looping a loop one time is one iteration. So here, coming back to this example, using a while loop to print something 100 times. Here's the code, and here is the flowchart. We're going to have this count variable, and it starts at 0. And is count less than 100? If it is, let's go ahead and print programming is fun. Then let's increment count. So now count is 1. So we're one step closer to being done with the loop, and we're going to come back up here again. Is 1 less than 100? It is. So this is true. We're going to print programming is fun, and now count is 2. Come back again. Is 2 less than 100? Sure is. So we're going to keep doing this over and over. Printing programming is fun, incrementing count. So now count, every time we increment count, it's one step closer to being at 100. And so let's actually go look at the code of this. Here, I have it already typed up for us. So while it's already typed up for us, though, do notice we're not going to do it 100 times. I have it only going to 5. So I've declared this count variable. It's initialized to 0. Let me go ahead and clear this out down here. And we're going to loop as long as count is less than 5. So that's what this while loop says. Here's the Boolean expression. Let me zoom in even more. While the count is less than 5, keep on looping. And what are we going to print if it's less than 5? We're going to say loops are easy. And after we print loops are easy, we're going to increment our count by 1, which means we're one step closer to completing this loop. So now count will be 1. Is 1 less than 5? It is. We're going to again print loops are easy because this is true. So we're going to enter, and we're going to enter the while loop and execute the statements in the body of the while loop, which are all indented over 4 spaces. We will then print loops are easy, and we will update count again. And we will exit once this Boolean expression is no longer true. So if 1 is less than 5, it's true. 2 is less than 5 is true. When count becomes 3, even 4. When count is 4, 4 is less than 5, it's true. But when count becomes 5, 5 is no longer less than 5, that will be false, and we will exit the loop. So here's a great example of where Thani, we've talked about this IDE that I use. Thani is a wonderful educational IDE. It is trash from a professional perspective, but from an educational perspective for new programmers, for babies, it's wonderful. And the beauty of Thani comes in its debugger. So let's debug this, which really just lets us step through all of the code. So here, and let me turn on variables as well. View variables. Over here on the right side, we have our variables. So let's step through all of this. I'm going to just keep repeatedly hitting F7. So we have our count variable is 0. Over here on the side, we see that. And now notice that the interpreter it sees this entire while loop as one big block of code. And now it's going to step in and it's going to look at the Boolean expression. Is count less than 5? 0 less than 5. That's a true statement. So while true, we will now enter the while loop. We're going to print loops are easy. That's going to get printed. And we're now going to increment count by 1. So if you notice on the right, count is 0. But after we execute that, now count is 1. And we come back to the while statement. While 1 is less than 5. That's true. So we again enter the while loop. We execute the body of the while loop. We print this statement, loops are easy. We increment count. Count is now going to become 2 if you look over here. And now we check, is 2 less than 5? It is. That's true. We're going to print loops are easy. We're then going to increment our count again. Count will become 3. Is 3 less than 5? It is. That's true. Again, we enter the while loop. We execute the statements in the body of the while loop. We print loops are easy. We're going to increment our count. Count becomes 4. 4 is less than 5. That's true. Again, we enter the while loop. Again, we execute the statements in the loop body. We print loops are easy. We increment our count. Our count, notice it's 4 and it's about to become 5. So we've printed 5 times from count equals 0, 1, 2, 3, 4. So from 0, 1, 2, 3, 4. We printed 5 times, but now count is 5. And when we continue, is 5 less than 5? Nope. 5 is not less than 5. This is false. So now we will no longer enter into the loop body. We will in fact finish this loop. Lines 5 through 9 have finished. We're going to now perform the next statement. We will execute the next statement that comes after the loop, which is line 11. I just made a print statement to show that we're now after the loop and the program has concluded. So very important to use that debugger. It's very powerful as an educational visual to watch every step of this loop as you're iterating through, looping through, iterating through every step of the loop. Very, very important to do this. So another example. What if we would like to sum the very first 10 integers from 1 up to 10? We want to add 1 plus 2 plus 3 plus 4 plus 8 plus 9 plus 10 all the way through. We can use a while loop to do this. Our algorithm is simply as follows. We're going to loop 10 times, right? We're going to iterate 10 times. And here, let's even keep a constant called num times to make it seem better. We don't need to do that. I could have just said less than 10, but we'll keep a constant called number of times or num times. We also need to have a variable sum. This variable sum will be used to keep track of the current sum of those values. We're going to add 1 to some, then we're going to add 2 to some, then we're going to add 3 to some. You'll see as we go through this. We also need a counter variable, like we just had on the last problem. This counter variable is going to be used to make sure that we're looping strictly 10 times. So in this counter variable, though, this time it's going to start at 1. And think about why it may start at 1. We could count from 0 to less than 10. That would loop 10 times. On the last example here, we counted from 0 to less than 5. That printed 5 times, which is what we wanted. I could have also, what if I looped from 1 to less than 5? That will have printed only 4 times. So if I want to start at 1, how can I print 5 times using this example? I would have had to have said less than equal to 5 or less than 6. Either one would have been sufficient, but maybe you want to visually see those endpoints. You want to see the 1, you want to see the 5. So some people like and they prefer a less than equal to 5. So we could have looped from 1 to less than equal to 5. We chose to loop from 0 to less than or equal to 4, would also give you 5 times, or less than 5 will also give you 5 times. It doesn't matter. It depends on the scope of the problem and the purpose of the problem. If I want to print 5 times, I frankly could have done from 22 to less than 22, 23, 24, 25, 26 to less than 27. That will print 5 times. Or I could have said less than equal to 26. This will print as well 5 times. So all of these would print 5 times, but it's now a matter of, does it help us for the purpose of the problem to start at a particular value? In this case, for this current problem, because we want to count from 1 up to 10, it's actually more valuable for us to start that counter at 1. Because we're going to use the count variable to count, but we're also going to use the value inside the count variable to add it to our sum. And so we're going to count 10 times. Each time we're going to add this count variable, the value inside it, to our sum. And let's go through the code. So here I've once again typed this one up. We're going to talk about it, and then we're going to trace through it. So we have these variables that I mentioned and these constants. So I made a constant, which as we know is all capitals, num times equals 10. I didn't need to do that. I could have just come right here and said less than or equal to 10, but just to get more practice using constants. So if you want to loop a strict number of times, why not make that as a constant, set it equal to the number of times you want. We have our counter that we're starting at 1. And we also have this sum variable. We're going to constantly be adding the value inside this count variable to our sum. So let's take a look at this loop. We want to loop as long as our count is less than num times, or equal to, less than or equal, let me make this caps, equal to num times. We want to keep looping as long as count, which starts at 1, is less than or equal to 10. And at every iteration, at every loop of the loop, at every iteration, that's why we use the word iteration. It sounds strange to say at every loop of the loop. At every iteration of the loop, we're going to take the previous value of sum, which starts at 0. We're going to add count to that previous value, and then we're going to save that inside sum. So for clarity, imagine, remember, we want to do 1 plus 2 plus 3 plus 4 plus 5, all the way to 10. Let's pretend it was just 1 plus 2 plus 3 plus 4 plus 5. And I want you to add all of those values inside sum. Well, if sum starts at 0, when we add just 1 to sum, now sum is going to become what? It's 1. Now when we add 2 to our sum becomes what? 3. It's 1 plus the 2 is 3. Now if we add that third value to sum, which is this 3, well, it's going to be 6, right? It's 3 plus this 3 is 6. And then when we want to add this 4 to our sum, we'll get 10, because it's 4 plus 6 is 10. And then finally, when I want to add this fifth number, it's going to be 5 plus 10, we're going to get 15. So this is what we're going to be doing, and this is what our loop is going to take care of for us. So we're going to constantly take the previous value of sum, add our count to it, and then save it back inside the sum variable. Then we're going to increment our count by 1, so we're one step closer to finishing this loop. And then finally, we're going to retest this Boolean expression. Is count still less than num times, or less than equal to num times? If it is, loop again. Sum equals sum plus count. Once again, add count to the sum, resave that into the sum, and then update your count. Keep looping until this condition is false, and then print. So let's run it first, and we see the sum of integers from 1 through 10 is 55. So what follows now is let's simply debug this, and let's see what the debugger shows us. Let's clear this out, and let's debug this and go through every single step. So here we have this variable num times is 10. We have our count is 1. Sum is 0. Notice your variables on the right side. They're going to be small for you to be able to see, though. I can't increase that size. We now see that the interpreter views this entire while loop as one block of code, and it will now evaluate this first Boolean expression. While count is less than or equal to num times, count is 1. 1 less than or equal to 10, that's true. So we enter the while loop, and what do? We come to the right side of this assignment. We start on the right. We take the previous value of sum, which is 0. We add count to it, 0 plus 1 is 1, and we save that inside sum. So if you notice right here, sum is now 1. And we update count, count will become 2. Is 2 less than 10? That's true. Now we're going to do what? We're back to this assignment. Start on the right side. Sum is 1. The count is currently 2. 1 plus 2 is 3. That gets saved into your sum. Your sum is 3. Now your count will update to 3 as well. Is 3 less than or equal to 10? That is true. So now we once again perform this assignment. Sum is currently 3. 3 plus the count, which is 3, is 6. We save that into sum. Sum becomes 6. If you look right here, sum is 6. So now count will become 4. Count is 4. Is 4 less than or equal to 10? That's true. I'm going to go a little bit faster in just a moment. We're at the assignment. Sum is 6. 6 plus the count is 4. That's going to be 10. Now the sum is 10. And count is 5. And let's just go through faster. I'm going to skip the next few without explanation. I'm going through this. Count is currently 6. Sum is 21. So what is count? Count is 7. 7 less or equal to 10. That's true. Sum is 21. Count is 7. 21 plus 7 is going to be 28. So you'll notice that sum now becomes 28. Count becomes 8. And we're close to finishing. 8 is less than or equal to 10. That's still true. So take 28, add 8 to it. That's going to be 36. Sum is 36. Count is now 9. 9 is less than or equal to 10. That is true. We're going to take 36 plus 9 is 45. That's our new sum. Count is now 10. 10 less than or equal to 10 is still true. Sum is 45. 45 plus 10 is 55. That will be our final sum because count is now 11, and 11 is not less than or equal to 10. That is false. We will no longer enter this while loop, and we will come down to line 14 and execute this statement, which simply says the sum of the integers from 1 through 10 is, and we plug in that sum, which is 55, and we get our final answer. This debugger is fantastic as an educational tool. I really encourage you, pause the video anytime you ever see me coding, but in particular now, to pause the video to make sure you code this up and run that debugger yourself. You click the bug button and you hit this second icon here. On a Windows-based machine, that would be F7. On a Mac, I'm sorry, I don't know, but you can, when you put your mouse over it, it'll tell you. You could just keep clicking it if you want, but I just personally prefer to hit the keyboard shortcut. So that debugger, hugely, hugely important to go through this code and debug it and understand how that works in the Thani debugger. So what would be wrong with this code? Same problem. What would be wrong? And think about that with this code. The problem here is that this line of code where we're updating our count variable, it's not indented inside the while loop. So we used count as a variable instead of I, because count is more appropriate. Notice what happens here when I debug this. I don't want to do that. Let me hit stop and debug it. So when I debug it, I'm going to quickly come through. Count is 1. 1 is less than or equal to 10. We update our sum. Take 0 plus 1. Sum is now 1. What happens now? We come right back up here. We never actually make it to here because this is not part of the while loop. Which means what? Count's still 1. 1 is going to always be less than 10, and we will never exit this loop. In fact, this is an infinite loop, which is something we're all going to experience as new programmers. This will never stop. If you run it, if you hit stop, and then we try to run this, we're just going to wait and wait and wait. Sum is probably in the billions right now. It's just going to keep on summing and summing, and it will never, ever stop because we didn't give it a reason to stop. So indentation, super, super, super important. Also important for new programmers is to avoid a one-off error. So new programmers, this is very common. because on that example of printing 10 times, for example, if you want to go from 1 to less than or equal to 5, that would be exactly 5 times. But if you started at 0 and you said less than or equal to 5, that would be 6 times. But what if you only wanted 5 times? So really paying attention to the starting value of count and when you want to stop looping, or until when do you want to continue looping. So if you say start at 0 and loop as long as count is less than or equal to 5, that's going to go from 0, 1, 2, 3, 4, 5, which is actually 6 times. So you have to pay attention to when do we want to actually exit this loop and pay attention to those variables within the Boolean expression. So here's the same example. This would actually print 101 times because it's starting at 0 and it's going to continue printing as long as count is less than or equal to 100. So we have to be careful with that Boolean expression and know when we want to stop. If I want to continue looping while it's less than or equal to 100, no problem, in which case I should have started my count at 1. Okay, here we go. Write a program that sums together 5 randomly generated numbers where each number is between 1 and 10 inclusive. The seed for your random number generator should be the string Python. So let's go right to the problem solving phase here. We want to do what? Sum together 5 randomly generated numbers. Each number should be between 1 and 10. So that random numbers, we need to import random. Let me come make a new program here. File, new, save, and let's call this sum random numbers. So I need to import random. Import random. It's a great comment. Then I need to set the seed because we want to have the same random numbers as you're following along. So random.seed. And what did we say to set it to? It's probably right here. Nope. Set the seed to the string Python. Okay. And what else in the problem solving phase? Generate 5 numbers. We want to do that in a loop. Generate 5 numbers, add those to a given sum. So we need a sum variable. So variables needed. We could have a constant again, num times equals 5. We need a sum equals 0. And of course we need a count. So do we want to loop from 1 to 5, or we can go from 0 to 4? We'll start at 0 this time. And we need to call the randint 110 exactly 5 times. We're not going to write 5 statements. We're going to do a loop for this. So the next slide is simply showing the code. So let's go through this here. We need a while loop. We'll talk about the condition in a moment. What is that condition? Let's go ahead and type the comment. Keep or loop as long as count is less than num times. That's our condition. So we can go and write that. As long as count is less than num times, keep on looping. What do we want to do at every step of the loop? I want to generate a random number between 1 and 10. So let's just call it num equals random.randint 1, 10. We want to add that number to our sum. So sum equals sum plus num. And then we want to update our count to be one step closer to finishing the loop. So count plus equals 1. And then after the loop is finished, we're going to do what? Print the sum of those 5 random numbers. The sum of the numbers is placeholder dot format sum. So let's go ahead and run this and see what we think about it. Let me zoom out just a little bit so y'all can see everything on the screen. And here we go. The sum of the numbers is 23. Now maybe you want to see the number each time, so let's print the number just for kicks. Print num. Let's run it again. It's going to be the same 23 because we're using a seed, so we're going to generate the same numbers every time. 7 plus 3 is 10, plus 7, 17, plus 1, 18, plus 5, 23. Just to give you a visual confirmation that we're doing the correct thing. So this is not a whole lot different than this one. We just summed numbers here. But here, what were we summing? We were summing 1 through 10. So we were using the value in our count variable. On this program that we're looking at here, the only purpose of our count variable was to count. In which case, we could have started at 0. We could have started at 1. We just wanted to count 5 times. Frankly, you could start wherever you like, right? I didn't need to use num times. I could have said count is 740. I could have said count is 743, and we want to loop as long as, I gotta think, 3, 4, 5, 6, 7. It's so sad. 747 or 48. As long as count is less than 748, that will do the exact same thing and give you the same sum because we're looping 5 times. That's silly. Why would you do that? You would not. But I'm simply demonstrating that count here is just a counter variable. We're not using it for the summing of this particular problem. So we're going to go from 0 to less than 5. At every iteration, generate a new random number, and then add that number to our sum. Now, I coded it like this. Since we're new programmers, we're maybe not as comfortable always using the augmented operator, which is this right here. I think most students are okay when you use this augmented addition operator when we're merely adding 1 to a value. I don't think you need to have count equals count plus 1. Most students are pretty comfortable with count plus equals 1. Well, in that same vein, I did not need to say sum equals sum plus num. I could have just said sum plus equals num, which is what I would prefer to do. Make sure you're comfortable with that as well. Run your code, we get 23. Hopefully this one makes a bit of sense. So now we're going to jump to the next problem. Here's the code for this one, another one. Let's write a program to print out a conversion from miles to kilometers. Pretty straightforward. We're going to show you a chart, and we want to print that chart, this table of a conversion from miles to kilometers, which means we need to know that conversion factor, that 1 mile equals 1.609 kilometers. The program specifies that we need to have the kilometer value be shown with 3 digits to the right of the decimal. And we should also assume that the first column of data takes up 12 total spaces, because we should use formatted printing to make the table look nice. So here's the table. Just to examine it, we want to print the mile values from 1 through 10. So we're going to loop 10 times. And at each iteration, we're going to print the mile value, and we're going to print the equivalent kilometer value, remembering that 1 mile is 1.609 kilometers. Come to Thani. Let's make a new program. Let's save it. Miles to kilometers. And let's start. So we need to do what? We're going to have some variables. Variables used in the program. Miles equals 1. We will be using kilometers. Do we want to have conversion factor? No, I could say conversion factor equals 1.609, but I'm not going to do that. We'll just hard code that directly when calculating our result. So before we print this table, or print the values of the miles 1 through 10 and their equivalent kilometers, we do need to print this little header, miles, kilometers, right? So let's start with that. Print the header. So print, and the problem stated that this first column of data is 12 characters wide. So we can use that fact, and I can just do this. I'm going to print it just like this, dot format, miles, kilometers, and then inside the placeholders, I'm going to come right here and say colon left 12s, and then here colon left S. But I'm not specifying how large that right column is because there's no need to. But the left column, we need to specify how large it should be. So we need to now loop. How many times? Loop until what? So now let's go back to the problem. We really shouldn't be coding yet. Problem solving phase. How many times do we need to iterate? Well, you look over here, it's 10 times, right? So we're going to loop 10 times, loop until miles equal, loop, I'll say loop as long as miles is less than or equal to 10. So while miles is less than or equal to 10, keep on looping. And what's the very last step of the loop going to be? Update or increase miles by 1. So miles plus equals 1. So miles starts at 1. 1 is less than or equal to 10. This will be true. We're going to do some stuff. We're going to print something, perform a calculation and print. And then we're going to update miles. So then miles will be 2, and then 3, and then 4. It'll keep looping as long as miles is less than or equal to 10, which is precisely what we want. So we have a counter variable. In this case, it made sense that that counter variable could just be our miles value, our miles variable that we're ultimately going to be using in the calculation. At every iteration, compute the number of kilometers and then simply print the result. So let's compute the kilometers. Kilometers equals miles times 1.609. Let's make a comment here. Compute the kilometers. And then here, comment for print the result. And the result is going to be this one line. So what's nice about the fact that we've already done this formatted printing line, I can just copy paste that right here, and I'm going to edit it. What needs to get printed now is not 2 strings, miles and kilometers. What needs to get printed is going to be the value miles followed by the value kilometers. And so here we're not printing S. This is going to be a D because miles is an integer. And here we need to print 0.3f. I believe the problem said 3 digits. We'll come back. It said 3 digits to the right of the decimal. So we're going to print 0.3f for the kilometers. So that's it. So if I come here and I run this now, let me just make a little print statement afterwards. Here we are after the loop. Just so you can see that when you're done with the loop, the loop finishes and will come to line 19. We run the code, we get the entire table. Is it correct? 16.090, of course, times 10, that makes sense, 14.481. So you should code this up, make sure you understand it, but if there's even the slightest bit of confusion, what should you do? Debugger. Come to the debugger and you walk through every single line of this, make sense of it. We don't need to look at that print statement. That prints is 1, the number of miles. Is it less than 10? It is. Compute the kilometers, which is miles is 1 times 1.609. We get our kilometers. We print that value. What do we do now? Miles is 2. Is 2 less than or equal to 10? It is. Compute the next kilometers. Print it. 2 miles is 3.218 kilometers. Update miles. Miles is now 3, as you see here. Debug this. Go slow. Take your time. Make sure you understand what's happening at every step of the iteration. Here's one particular implementation. Looks pretty similar to what I just did. Looks almost identical. Perfect. Good consistency. Last problem, repeated subtraction. We've seen previously a one-off subtraction question where we ask a third grader, we present to them a random question of what is 8 minus 3. We scan their answer and we print correct or incorrect. It's a one-off. Well, if they get it incorrect, instead of just printing incorrect, how about we print that's incorrect, try again, and then we ask them again and again until they get the answer correct. So problem solving phase, let's jump right into it. The output here is most important to just examine to make sure we understand what we're being asked to do. So we need to present the user with a question. Please answer the following. 9 minus 5, the blue is their input, they enter 4. You got it. What about, please answer the following. 6 minus 4, 3, that is incorrect. Please try again. 6 minus 4, 2, you got it. So this is the best way of understanding what you need to do is by studying this output. And let's even leave that right there and come over here to our Thani, new project. Let's call this save. And what was it called? Let's call it repeated subtraction. So what do we need to do? We need to, first of all, look at the problem solving phase. Generate two random numbers. Make sure the first is not smaller. The storyline was these third graders are scared of negative number answers. It's too much for their mind. So no problem. We're going to therefore swap the two generated numbers if num1 is less than num2, thereby guaranteeing a non-negative answer. And then we're going to ask the user to enter the answer, and we're going to scan their answer and save it in the variable answer. Let's do that once. So import random. Let us do now generate two random numbers. Num1 equals random.randint 1 through 9. Num2 equals random.randint 1 through 9. And now let's actually follow along with the exact look. Please answer the following. We'll do this afterwards. We'll generate the two numbers once. Print info to user. Please answer the following. Cool. And notice we have a blank space, it looks like. I can't tell, but please answer the following. We need to ask them this question. We need to, before doing so, we need to, as we said, swap num1 and num2 if num1 is less than num2. So if num1 is less than num2, we're going to swap them using simultaneous assignment. That's pretty straightforward. Please answer the following. We're going to print the question out for them. Let's go and type answer equals int input. And then right here inside the input, I want to put this exact statement. So I want to say, how about 1, 2, 3, 4, placeholder minus placeholder equals this. Okay. And then I want to say dot format num1, num2. All of this should be hopefully straightforward because we've done this before. And then we would have simply asked if answer equal num1 minus num2, right? If their answer was, let's call this user answer. If user answer equal num1 minus num2, so if they got it correct, we would have printed correct. Or let's just say you got it. You got it. But else, we would have to print some incorrect answer. Else print that is incorrect. So this is what we did previously, where it's not inside a loop and it's just a one-off. Please answer the following 5. That was not correct. Where's the word answer at? It says it's not defined, and I used it right here. User answer. Run that again. They enter 2, you got it. Let's run it again. They put 1, you got it. Let's do a wrong answer. And 3 minus 2, let's put a 5. That is incorrect, right? So this was a one-off. Well, we want to do this now with looping. So the idea here is in this loop, next we have a while loop, and in this loop, and if their answer was wrong, then we want to tell them it's wrong and repeatedly ask them. So instead of saying if they got the answer right, we want to say loop as long as the answer is wrong. So here, it's not going to be if. I'm going to say while the user answer does not equal num1 minus num2, we want to print to them that is incorrect. And now we want to re-ask the question. Okay, we want to re-ask them the question. After printing it's incorrect, what do we need to do? Let me come over to the previous page. Please try again. That is incorrect. Please try again, colon. And we once again, on the very next line here, we repeat the question. So I'm just going to take this entire line. I'm going to repeat it right here. That is incorrect. Please try again. And we again ask the question, we scan it, and we're going to again test it. And if it's incorrect, we have to try again and again and again until they get it right. When they finally get it right, this while loop will be false. We'll exit the loop and we will print, you got it. So let's run that a few times, then we'll talk about it. Oh, I typed it wrong again. Where did I do that? I must have put an equal up there on accident. Typo while just hitting something. All right. 23, that is incorrect. 3, that is incorrect. 2, you got it. So it keeps asking us over and over. 1, 4, 78, 96, 0, 3. We're going to enter 2 finally. You got it. And let's put the correct answer right off the bat. You got it. So here's one that you want to code up, and it's worth, very much worth, coming through here and doing a debugger on that, which this is the last question, and I'm going to keep this under 50 minutes, so I'm going to end this shortly, but it's worth looking at the debugger here. So when I debug this, we generate 2 numbers. Num1 is 7, num2 is 8. If 7 is less than 8, it is. We're going to swap them. So now num1 is going to be 8 and num2 is 7. We ask them to answer the following. What is 8 minus 7? And it's waiting for me to put some input. Let's say I put 2. That's wrong. And so we're going to check the answer. While, now we're in the loop. While the user answer of 2, while it does not equal the correct answer, which is num1 minus num2, which is going to be 1. 8 minus 7 is 1. While the user answer 2 does not equal the correct answer of 1, do this. That's a true statement because they put the wrong answer. We print this is incorrect. Please try again. And we have to once again ask them to put an answer. Let's say we put 3. 3 is still incorrect. It does not equal 1. Therefore, we have to do it again, right? We ask them the question again. Let's say we finally put 1 and we keep debugging it and we see that while 1 does not equal to 1, well, 1 does not equal to 1, that's false. Therefore, we will not enter the while loop again and we will simply print, you got it. Let's see if that differs at all from the solution that I previously coded here on the slides. So nope, it looks pretty much the same. So the only difference is I was printing on one line and then scanning on the next line. So we've seen a lot in this video. We've introduced loops. We've seen some very basic looping problems. We looked at this print 10 times, summing the numbers, summing random numbers, but now even these miles to kilometers and repeated subtraction. 5 new programs that I hope you coded up each one of those on your own, debugged that program, went through, found any mistakes you made, any maybe holes in your understanding, patched it up. If there's anything that's missed, anything you need, as always, reach out, ask a question, leave a comment. It's been fun. Take care, everyone.